So, a pleasant good morning to all of you. With much happy, I connected with you in this second day session. A well beginning will always proceed in a good manner for a grand success. Hope so. Our program is also blessed by the Almighty with well beginning and is proceeding in a very good manner to end up in a grand success. In the second day session, the first session is going to be shared by Dr. T. Selvaraju, Associate Professor from the Department of Chemistry, Bharathiar University, Coimbatore. We welcome you, sir, to this FGP to share your ideas. Sir has received his PhD from Madurai Kamaraj University. During his research time, Sir has received both JRF and SRF fellowship from Madurai Kamaraj University. And next, he has done his PDF in Pusan National University, Busan, South Korea. Sir has vast area of research and experience, about 20 years. For the research thirst, he received DST CERP project in the year 2012 and 2016. Certificate of Appreciation as a Reviewer Award from the American Chemical Society, RCS. Sir has given hottest top 25 articles many times. Sir has also received both the oral and poster presentation awards as a best winner award many times. His area of interest are electronics, biosensors, sonochemistry, energy storage materials, supercapacitors, novel synthesis of monodispersed metal nanoparticles, semiconductor nanoparticles, calorimetric assay, conduction polymers, light-emitting diodes, organic thin film transistor, organic light-emitting diodes in OLED applications. For an additional responsibility, he is a reviewer for many reputed journals, organized many conferences and workshops successfully, as a resource person, promising resource person for many programs. So, we are very happy to connect with you, sir, as a resource person for our FTP also. Sir has guided 2 PhD candidates, and now, at present, 2 candidates are under his research training. We are proudly welcome you on this forum, sir. Over to sir. Vanakkam, sir. கேட்கல சார் சார் ஆடியோ இல்லை சார்.
Yeah. Good morning,
Yes.
madam.
Sir. Thank you, sir.
Good morning. Yeah. So, thank you for your nice introduction, madam.
Thank you, sir.
First I would like to thank the Department of Chemistry, University College Engineering campus of BIT for just organizing this AICTE Atal online FDP program in the very important topic these days needed, like strategies and outcomes to enhance the sustainable green environment. Okay, so these days this is a very important area. We have to think every day or normally. So how to create a sustainable environment or how to produce sustainable energies. So in this domain, that is organizing a program is very highly encouraging. So first I should appreciate the organizing committee members, Dr. Kanimuli and the HOD, Professor Jyoti Venkatachalam, for putting forward and getting the kind of a sponsorship from the central government like Atal FTP programs, and thereby, and I also be privileged to be here standing before you in delivering a lecture in these sessions. So thank you once again, madam. And shall I start the presentation, madam, or everyone has joined?
Yes, sir.
Okay.
Many
okay,
participants are here. You can start.
Okay. So my topic here is how to justify the topic. I mean, by means of. So here I'm just going to share a few things about, that is how the kind of carbon-based materials are normally employed in terms of creating the. Madam, my
The
slide
screen
is
is visible.
visible to everyone?
Yes, sir. Yes, sir. The screen is visible, sir.
Okay. So, so I just want to share something about how the kind of carbon-based sustainable materials can be used or can be introduced, or how to enhance the efficiencies in terms of energy storage applications. And if I see the newspapers of today, I have seen that the last 1 year, the tax collected from the kind of petrochemicals, I mean petroleum products, is approximately 3.5 lakhs crores. Okay, so this is a statistics given in the Hindu Daily today. That is the last 1 year, the government of India has collected the money of 3.5 lakhs rupee, 5 lakh crore rupees as a tax only from the petroleum products. Okay, so if you check about our Tamil Nadu government budget, I have just now I checked about the Tamil Nadu government budget, and last year 2020 Tamil Nadu government total budget value is less than or equal to only 3 lakhs crores rupees. Okay, so that much amount of money is collected as a tax. You just imagine that how much amount of total money we have paid and how much amount of crude oil we have used in the last 1 year. Okay, it's a kind of unimaginable things are so the kind of energy or kind of a non-renewable or a kind of a petroleum energy we are utilizing day-to-day activities. So these days, many companies are thinking about how to go by means of harnessing the kind of renewable sources. This is not the new thing, but starting from 1980s itself, many people are just studying. But the very important problem here is in terms of thrust or in terms of in terms of efficiencies. Still that is a kind of things. But to some extent, I think that these days many kind of green vehicles are just rotating or coming around and emerging these days by means of in order to reduce the kind of carbon footprints or kind of reducing the kind of importing the kind of petroleum products. So here I just want to share some of the contents. These are the areas I want to touch today. That is before going to about discussing about a kind of how the carbon is going to enrich carbon can be used for energy storage applications. Some of the few slides, starting slides, I want to share about some of the thought-provoking activities of strengthening of chemical science courses. So why I just added these things means nowadays the new education policies came out, and we the kind of educators need to have clear-cut ideas about how to introduce the kind of content or concepts these days, because the LKG children or UKG children itself these days are having a kind of mobile phones or computers, or they can surf anything in the Google. So the whatever informations we have collected in the maybe at the age of 20 right now, at the age of 4 or 5, the kids are learning those kind of activities. So still, if we want to give the same kind of methodology, and maybe it is not sufficient or on par with these 20 millennium kids. That is an important thing. So how the kind of is the screen is sharing, madam?
Sharing, sir.
The screen is sharing, no? So
yes,
if there is any disturbance, just let me know, madam, because
yes, sir. Sure, sir.
Yeah.
Sure.
Okay. So the first content is I want to share some of the informations about strengthening of chemical science courses. And subsequently some of the work what we have experienced in our laboratory, that is we want to share it like what do you mean by a kind of galvanic displacement reactions, or how a kind of a different phase of MnO2 can be used in the case of energy storage applications, and how the kind of manganese oxide kind of a perovskite can be used for energy storage and other kind of water splitting or oxygen evolution kind of reactions. Kanimali madam, whether the audience are fully chemistry oriented audience, madam, or a general science oriented audience, madam?
Interdisciplinary audiences, sir.
Okay,
We
okay,
have
okay,
from
okay.
mechanical engineering, manufacturing technology, EEE, economics, zoology.
Yeah,
So we
yeah, yeah.
have interdisciplinary participants, sir.
Okay, 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 okay. Because if we are interacting in person, we can ask one-to-one interaction can be carried out, and the virtual platforms, okay, so we are unable to do all those things. Okay,
Yes, sir.
no problem, no problem. Because based on the audience attitude, we can have it. No, that's why I'm asking.
Yes.
Okay.
Sure.
So here, so we just want to, so it is not only for strengthening of the chemical science courses. Okay, in each discipline, we can think it of how the kind of things can be carried out. So one thing is how to strengthening the courses. I just taken from this kind of Journal of Chemical Education from the ASCS Journal of Chemical Education journals recently. So what they are saying is, if you want to strengthening the kind of basic courses, science courses, and need-based science in the curriculum makes more attractive and motivates the students' curiosities. So the technology is growing by leaps and bounds, and the laboratory practice is far from practical applications. Okay, so we can visually see how the kinds of things are happening. So what we are practicing and what we are exactly happening, okay, it's not matching. So although one could argue that science should not be judged by the value of its use, it is a common fact that the students are more likely to prefer a practical knowledge approach. Okay, that is the most demanding things is needed. So it's as educators, it is our job to update our strategies to the new findings and the trends. So the teaching the fundamentals is fundamental clearly, and encouraging students to study and learn by themselves is the demanding thing is needed. And in this context, we the educators needs to propose a simple practice in which the students can learn, okay, a kind of a chemical science behind the trust domains like energy, food or health and etc. Okay, so how to carry out, okay, I just checked some of the exercise, almost 7 exercise, 7 types, they just, classified. So these are the kind of module can be introduced to students in the case of first years. So they're reforming the large foundational courses, and in the case of in the westernized area countries, by means of reforming the large foundational courses and what they feel in terms of success and challenges they have shared here. And in recent years, educational reforms in undergraduate science courses or technology and engineering and maths course educations, that is STEM education, become more prominent, particularly in foundational courses. So the frequent calls for educational reforms in colleges and universities are becoming louder and louder in these days. So briefly, a major success and challenges encountered during the full implementation of the new chemical thinking curricula across all sections of the large course serving thousands of science and engineering majors every year. Besides, the goal and structure of the alternative curricula, as well as its impact on students' learning, and the work seeks to provide insight into the institutional conditions and resources and constraints that hinders the success of major educational reforms. And if you talk about here, so the concerned chemistry educators or any science educators or technology educators have proposed and engaged in the implementation of diverse projects to improve the students' learning outcomes, particularly in foundational courses. It is focused on developing and implementing and evaluating the effects of more student-centric teaching strategies, and instructional models include the process-oriented guided learning inquiry or education models are a peer-led team learning pedagogy and the flipped classroom approaches and etc. So these are the kind of tools or the kind of attitudes they just developed, and these different pedagogies of engagements are content neutral, and it can be independently depend on the nature of curriculum. So for example, so if you want to think about the foundational courses and the reformations, so there are some essential questions that guide the presentations and discussions and integration of the content in the chemical thinking curricula. So for example, if the content is about the chemical thinking, okay, so as a educator speak, so based on your domain, you can think it up like this. So we can start it like this. How do we do, if the title is about a chemical thinking, how do we distinguish the substance? How do we determine the structures? Or how do we predict the properties? Or how do we characterize the process? Or how do we predict the chemical changes? Or how do we control the chemical process? And how do we synthesize the substances? Or how do we harness the energies? So likewise, in every kind of a domain, so we can have a lot of questions, and accordingly we can frame the different units in the foundational courses. So in the evaluation process of these reformations, they identified that there is an encouraging signs of improvement in the case of general chemistry courses or in general science courses. Whereas still there are several challenges have they faced, have to face by the educators, include that commitment of implementations and students' accountability and aligned assessment programs influence, etc. Okay, so how about we are committed, or how about the accountability with respect to students? The collaborative learning initiative would become one of the most successful agents, and through motivations and driving of the faculty involved in educational reforms through the city models of chemical thinkings. So I just want to share here another exercise or example that is, it is a simple reaction. So, okay, so the reaction is reactant A is converting into a product. Okay, so this is obviously we know. In day-to-day also we know when a milk is adding some curd, that it is converting into a full form of curd. So it is a kind of a bacterial reactions. Okay, so likewise, it is a kind of a compound A, that is a spiropyrin, can be converted into a compound, a kind of a fluorescent compound called as merocyanine. Okay, so the approach here is how a single reaction can thread ties of multiple core concepts. Okay, the case of chemical courses, that is kind of we can talk, the reaction is mainly because of the hydrogen bonding. So we can we'll go ahead in depth with respect to the hydrogen bonding and the equilibriums. Okay, so the equilibrium is balancing between how a reactant is converted into a product. So, okay, what is the fact driving forces in order to convert from A to B? So the equilibrium play a very important role, okay, in order to drive the reactions in a forward reactions or backward reactions, etc. Or in terms of quantum mechanics. Okay, so and about the molecular orbital theory or polymer chemistries and mechanical work and etc. So a single reactions, by means of threading these single reactions, multiple core concepts can be touched by the teacher, and we can introduce a lot of this kind of topics to. By this way methodology, if you just share or if you introduce the topics, so it will be really very familiar to the students' exercise. So the interconversions occurs in response to changes. Various factors can convert the reactant, spiropyrin into a merocyanine. But the thing is, what are the prevailing factors can frame it, and the framing of a number of different concepts in the same reaction may allow the students to see the connectivity in seemingly disparate sections. These days, most of the students can't sync between the unit 1 or unit 2 or unit 1 or unit 5. Okay, so we have to emphasize that that there is a relativity is there in terms of by means of introducing these kind of concepts. At the same time, provides a pathway for the students to gain confidence and comfort with carbon-based molecular structures before stepping into the organic chemistry courses. So here, as I told you, the same thing, that is how the kind of a small reaction takes place, that is how a kind of a ring opening takes place, and by means of ring opening, a non-fluorescent spiropyrin can be converted into merocyanine, and here we can talk many these kind of topics like so as I told you, if it wants to convert means by means of any external stimuli, here the equilibrium should be a forward reactions, that is the spiropyrin. If it is only in the forward equilibrium only, then the merocyanine can takes place, put forward. How the hydrogen bond, weak hydrogen bonding. So this is a kind of hydrogen bonding, and by means of what is a requirement to break this hydrogen bonding? So if it by means of breaking this bonding, obviously a non-fluorescent compound can be converted to fluorescence. Okay, so by means of UV light, if we expose the UV light, or by means of any stimuli, mechanical stimuli, if it happens, and there is a possibility to convert, and thereby what is the kind of work that takes place here can be understood. Okay, so that is the way by means of it. Obviously, it is if it were possible to introduce the concept so that they can understand the concept and they can apply it for some other. Okay, a kind of they can think it of in a lateral way in order to improve the kind of topics. Okay. So in the kind of this single type of single thread reactions, how we can frame a kind of a new content, like so as I told you, the energy, enthalpy, and the thermochemistry can be discussed in 2 hours. Yeah, and we can frame it as a unit 1, and about the electronic structures can be framed as a second. Okay, and it can be discussed for 2 classes, or the molecular structure, followed by the molecular orbital theory, or how the chemical equilibrium, because they, as I told you, the chemical equilibrium should be either a forward or a backward. If it is a forward means then the kind of a reaction can take place. If it is not forward means the reaction won't take place. And similarly, the entropy and free energy are the kind of things can be discussed, and what is the external factors like acid and bases play a role, and how about the kinetics and catalysis, because if a reaction should be carried out, okay, kinetics and catalysis need to play we have to understand the mechanism of kinetics and catalysis. So likewise, yeah, single reactions, okay, it is possible to frame a total curricula, okay, with a amount of 8 units, and obviously around 20 hours it can be discussed. Likewise, the course-based undergraduate research experience can be given to the undergraduate students, and that is development of a CURE, that is a course-based undergraduate research experience, and it is remains a successful one in the Western countries. And here the adoption rate is higher in the case of life science compared to the physical or chemical sciences. Okay, that is the real things happening over there, and an increasing number of course-based undergraduate experience, research experience. Okay, so for this activities, more amount of literature information is needed for the students, and we have to guide them in a proper way, and thereby still limited awareness of many institutional practices. And it is widely accepted that research as a high impact practice provided to the undergraduate students, and to afford a positive learning outcomes and aid in the meeting workforce objectives. And mentoring the research remains as a mainstay in interventions to the undergraduate students, and enriched from the beginning at the curricula, including their research experience to enhance the learnings. In developed countries, many of the benefits of mentored research experience like CURE are realized within the curricula. And so, for example, so I just want to say one thing, how a course CURE-based can be taught in the classrooms. So with respect to the chemistry aspect, I'm just given here. So you the kind of teachers of a different interdisciplinary domain can say a simple experiments can be introduced over there. Okay, so here what I want to say is how the hydrogen can be generated. Okay, because the hydrogen generation is important, needed for these days. So using a simple chemical called as aminoborane, okay, there is a possibility for hydrogen storages or hydrogen generation can take place. So the investigation of a borane as a hydrogen generator and how to store the storages can be ballooned over a past decade because of its relative stability and high weight percentage of hydrogen. Ammonia and other aminoborane may liberate hydrogen under thermal conditions or by heating. Okay, so here I just mentioned that when you just heat this aminoborane, there is a possibility to release the hydrogen gases. Okay, in the presence of catalyst, and the controlled release can take place. Okay, so then you can ask why the kind of hydrogen is not generated by these kind of activities. The problem is it is very expensive by means of using this aminoborane to release the hydrogen, because we know that if hydrogen can be released and with the help of oxygen, it is possible to construct a normal hydrogen oxygen fuel cell to act as a wonderful battery or a zero carbon emission batteries. So the discovery and understanding of a simple bench-stable catalyst of hydrogen evolutions from aminoborin will advance this molecular agent in hydrogen storage applications. So by means of introducing these kind of topics to the undergraduate students, and they may think it of easily, okay, so what is the alternate way to generate the hydrogen, or how the mechanism takes place by means of simple reactions. A reactant can convert into a product by the release of hydrogens. The student can design by themselves and explain their choices in experimentations. Then it is much easier to assess the objectives and ensure that would be an effective educational experiences. That is, here the genuine research experience may have 5 common behaviors. That is, how about the research activities, how they are addressed by means of experimental design and executions, data collections, data analysis, and the use of current instrumentations. And the discovery, that is the identification of new materials or a new catalyst. What about its relevance? That is how they address the relevance by means of hydrogen storage is a limitation in the adoption of hydrogen as a fuel. And in the case of collaborations, because most of the work, it is not possible to carry out by means of a single domain. Okay, so it is a need of interdisciplinary or collaborative things is needed. So we can inculcate the value of kind of collaborations or interdisciplinary kind of activities should be carried out by the students, can be inculcated in the first year when they enter into the colleges. The students worked in pairs and the class shared and considered all the data. And the iteration is the cycle of compound preparation, cycle screening, analysis, and etc. So this is the key. So based on these research activities or discovery, relevance, and the collaborations and the iteration items, it is how they have addressed accordingly. It is possible to just judge their kind of interest, or judge their kind of what is the input they have used, and the mark scoring can be easily achieved. Simply, it is not like just mugging up and just giving out. So how they just what effort the student have made it over this kind of cube-based research experience. Accordingly, it is easy for us in order to justify or given a respective kind of credit to the concerned students. Okay, so I think it is not relevant to you people. And the next one exercise is about a normal photometer. Okay, I hope everyone are aware about the photometers. That is, when a light is irradiated, the thing is some of the color may be observed and the remaining may be released by means of transparent signals, and it can be studied. Okay, so that's why our dress looks colors, right? So I'm just wearing blue color shirt. It means that some of the lights are observed, the remaining things are getting transmitted. Okay, likewise. So the thing is, if we talk about the electromagnetic radiations, we know that there is a range like ultraviolet radiations. That is, if you check about the wavelength between 200 to 400 wavelength, there is a kind of UV radiations. That is, and followed by, obviously, we know that the UV radiations are high energy radiations, and followed by the low energy of a visible radiation takes place. That is 400 to 800 nanometers are called as visible radiations. Because of most of the colors are absorbed in the visible radiations. That's why the beetroot looks like a pink color, or a carrot looks like an orange colors, or my shirt looks like a kind of a blue colors. Okay, so how to develop a kind of a photometer by a student, that is our ultimate aim. Okay, because if we check a normal UV spectrophotometer, whatever available in any laboratory, it may be taxing minimum 5 lakhs rupees. Okay, that is a normal budget. But in the student-centric, it is possible to fabricate a kind of these photometers, and with a very less budget of around 2,500 rupees. So I just share you how your students can design the kind of these photometers, and they can study the kind of colored substances, whatever colored substances. Okay, it may be a water effluents, or it may be a industrial effluents, or maybe a dye which are using in a kind of cotton, textile industries, or or in the case of leather industries, how they are using a kind of colored compounds. Okay, so the students can learn the principles and the practice of photometry through the project-based learnings. So it can address the challenges of measuring the unknown concentration of colored substances using a photometer and by knowing the design and how to build and how to test. And it can utilize the instrument to carry out the experiment and it fulfill the challenges. The experiments fit well into the analytical chemistry courses and take a standard of 1 hour lab period. So it facilitates the understanding of photometry concepts and improves the creativity, in terms of problem solving. So these are the kinds of, I just share here, there are three, it is a normal shoe kind of, shoe pack. We can use it that this kind of any kind of cartons. These days, the Amazon is right now delivering a lot of cartons, and any one of the carton can be used for this kind of purposes. So here I just shown here three kind of A, B, C. So what do you mean A means? So it is a kind of a light sources. Okay, so the light source is maybe a kind of a green laser pointer or a red laser pointer, whatever it may be. Okay, so this is the one, and the second one is a kind of any kind of a colored compound that is called as a sample holders, and the third one is called as a kind of a lux meter. I hope many technical people may aware of what you mean by lux meters, so it can collect the information. So by means of fabricating, so by using this kind of source elements, normally, so the laser light, if it passes towards the kind of sample, obviously some of the lights may be observed and the remaining things may be recorded over there in the case of lux meters. So here I just shown you that is when you just press it, the light falls on the sample and then it is so it is traveled and the lux meter is collecting the informations. So this is a way we can design this mission. And if you talk about the things means the lux meter is taxing around $10 US or point around $20 US, and normal sample holders maybe less than 100 rupees. So in a budget of 2,500 rupees, a student can design the kind of photometers and they can study whatever samples. It may be a kind of laboratory samples or a kind of any colored samples. So in an environmental centric, if they want to study something means, obviously it is possible to study those kind of studies. Information can be developed by them. And here the important criteria is if you see the results, I just shared one result. I just shared a kind of students built a spectrophotometer. That is the data collected from the student built spectrophotometer is a kind of a blue dots. It says that about its efficiency. Likewise, in a company made with a kind of, normally we know that Jasco or Shimachu or a kind of Perkin-Elmer kind of companies are developing a very high precise spectrophotometers. And if you study the same data in the kind of commercial spectrophotometers, the result variation is very meager amount. And we can, the unknown sample is giving a same kind of informations between both the student-centric spectrophotometer developed in less than 2,500 rupees and the other commercial spectrophotometer normally may cost about, I think, if some of them may also have the spectrophotometer, it may cost minimum 5 lakhs rupees in Indian market. So that is the why. What I want to say here is in terms of the efficiency is on par with the kind of commercial spectrophotometers. So the design is very simple. Only thing is how to carry out, and by means of if they fabricate by the student itself means they will be very interested to collect a lot of samples and they will study it and they can so improve the kind of designing methodology, or they can apply it for some other inventions and etc. So that is the ultimate idea about showing these kind of methodologies. So again, other one is a kind of how to develop a kind of new electric courses, and one such courses I just want to share it here. So 1 or 2 electric courses you can in your domain. So a simple topics can be chosen accordingly. So what are the parameters can be introduced in today's in maybe for example in terms of data analytics or artificial intelligence or in terms of augmented reality and etc. Whatever domain. So we can introduce a lot of content accordingly. New electric courses are can be generated by the educators and it may be really useful in these days. Okay. So the other important exercise what I've seen is in terms of, as I told you, how to break the water. Okay, so the water splitting. So the water splitting is really a kind of, if you see, okay, so that dissolving the gold is easier than breaking the water. So everyone, will agree that the gold dissolve is not easy. Okay, so that is a very precious elements. It can retain for a longer period of time, for many years. Okay, we know that in the case of Thiruvananthapuram, we have seen many vault in terms of Padmanabhapuram temple. Okay, there is a more amount of gold was there, and for many long years they have just stored over there. Okay, likewise, for many years, there is no corrosion may takes place. The reason is, so it won't undergo any kind of atmospheric reactions. Okay, what I want to emphasize here is, so that dissolving the gold is easier than splitting the water. Okay, it means that the water splitting is a very tedious process in the case of in normal scenarios. Okay, that's why we need some kind of a catalyst, and a kind of solar energy can be introduced over there in order to carry out. So normally, if you check about the photosynthesis process naturally happening, very rapidly the reaction takes place. There is a breaking of waters, and food preparations and starch preparation takes place. But if you want to mimic the system, in the laboratory, it is because the reason is here the breaking of water involves many electron process. So literally there are 4 electrons are involved over there. So thereby, possibly, it is a very one of the toughest thing of breaking the water. And the things are many upcoming activities are there now to break the water. And by means of it, if the hydrogen is released from the water, and thereby, it can convert into pure hydrogen. And by introducing the oxygen, obviously, the hydrogen and oxygen combined, it leads to create a kind of a green energy can be generated. Okay, that is a attitude. That is the very important thing here is in terms of oxygen evolutions. So in both the natural and artificial photosynthesis, an oxygen evolving catalyst is needed to catalyze the oxygen productions from the waters. So the monitoring the catalytic oxygen evolution reaction using the dissolved oxygen probe is a luminescent material that can continuously measure the concentration of dissolved oxygen. And to study the oxygen evolution process, identify and evaluate the necessary criteria for an active molecular oxygen evolution catalyst. And using the kinetic protocol, it is possible to calculate the turnover frequencies and the rate constant and etc. So here, what I want to say here is in terms of breaking, it is a kind of a 2 half cell process. That is, the water breaks means the oxygen will be released out, and obviously, the hydrogen can be released simultaneously. But the problem here is in this process, as I told you, the water breaking is a very tougher job. The reason is for any reactions, if you want to take place, the delta G is the one is called as a free energy change. So the free energy should be always negative for any spontaneous reaction. I hope most of you have come across the thermodynamics are a kind of thermal reactions, and most of the cases the free energy should be kind of a negative process in order to carry out by itself. So here for this water splitting, or in terms of in order to evolve the oxygen by artificially means and the free energy change is says as plus 475 kilojoules per mole. It means that highly it is a positive and it is a non-spontaneous process. Okay. If it is a non-spontaneous process means, and we have to assist this reactions to take off, and then the reaction can take place. Okay, so due to the slow electron transfer and high kinetic barrier associated in the removal of 4 electrons and 4 protons from the water, and thereby it is very sluggish to break the oxygen-oxygen bondages. Okay, so the sunlight provides a minimum thermodynamic requirement, and in an effective oxygen evolution using a catalyst, the reaction can take place. So normally, the oxygen evolution catalyst contains mostly ruthenium or iridium-based catalysts are normally used in terms of transition metal complexes and thereby structurally and electronically modified in order to improve the performances. So here you just see, as I told you, the free energy change is highly positive, and by itself it is a non-spontaneous. So by introducing these kind of things, the one oxidant is needed and a catalyst is needed to assist this breaking the waters. Okay, so the role of Syria is kind of an oxidant. It can it can make the atmosphere to undergo, or releasing the electron can take place. So to be robust under a higher oxidizing condition in water, and to undergo multiple electron and multiple proton steps, and to minimize the overpotentials. Okay, so here if you talk about the energy for the Syria, it is around 1.7 volt. Okay, but the requirement for breaking the water is 1.3 volt only. So obviously the energy can be transferred from, because you know that energy can't be prepared. It can be moved from one phase to other phase. Likewise, the energy from the Syria 3 or 4 to 3s3 will releases a 1.7 volt, and that energy can be used to break the water molecules, and thereby the oxygen can be released off. Okay, so this is the systematic approach. Likewise, it can be carried out. So this is the way, if you use this means by using a different catalyst, as it says that the ruthenium-based catalyst releases enormous amount of oxygen can be released out. And with respect, if your ruthenium means what is the concentration? Obviously, a 70 micromolar concentration releases a maximum amount of oxygen is released out, and that is the information. So as I told you, either the ruthenium or iridium are optimized in order to evolve the oxygen to the greater extent. So that is the thing, and thereby it is possible to break the water, and highly a non-spontaneous process can be converted into a spontaneous process with the help of this kind of methodologies. Okay, so these are some of the whatever topics today I just shared. It is a kind of things that is you can decide by yourself about with respect to the respective domain. That is what are the kind of new curricula, or new electives, or new practical oriented, or kind of a project oriented tool can be introduced to the student, and thereby so it can be creative, a more interest oriented or student centric contents can be introduced in the case of the undergraduate students. So that is the ultimate aim of this slides presentations. The past 6 or 7 examples I just shown you. Okay, on the next 45 minutes, I want to share some of the kind of how the sustainable carbon loaded materials can be used for kind of energy storage applications. So the first tool I want to introduce here is a kind of galvanic displacement reactions. It is also the same thing, that is the high energy content can be easily used for without any utilizing harsh chemicals. Obviously the designing can be carried out. So if you see the kind of atoms, so this is the kind of atoms. Here it is made of both palladium and platinum elements. Sorry, palladium and copper element is present. Okay, so my ultimate aim is at the periphery or at the surface, whatever element is present is full of copper, and those coppers should be removed by means of replaced by means of platinum. Okay, without using any kind of reagents or any kind of so harsh chemicals. Simply by using a kind of platinum sources, if you introduce it, and the reaction can take place. That kind of tool is called as galvanic displacement reactions. The reason is very same. Okay, it is not a kind of any non-innovative thing. That is a simple mechanism only. So the thing is, the energy of the platinum salt or energy is higher than the copper. So it says that its potential is around 0.755, whereas the copper energy is around 0.34. Okay, if you see the electrochemical series, I think you can understood familiarly what are its redox potentials. So the copper says at 0.34, or palladium says at 0.95 plus 0.95. So when a copper and palladium is present, okay, with the help of platinum, if you use it means the reason is the platinum energy is higher, so it can replace the copper. Okay, whereas it is not possible to replace the palladium. The reason is the energy of the palladium is higher than the platinum. Okay, so that's why our intention is okay. So if you are directly introduce the platinum, okay, because the platinum is very good in terms of you know that most of the carbon CO2 emissions and all can be restricted by the means of these platinum surfaces. So here the platinum can be by electroless. Okay, normally we can normally people will say as a electroless deposition. What the electroless deposition strictly means that it is called as a galvanic displacement. That is, one element can be replaced by other element because of the higher energy. Okay, so the displacement of copper by platinum is more thermodynamically favorable and kinetically favorable. Okay, that is ultimate aim. That is, things can carry out. So from this structure morphology, whatever copper is present, okay, the gray color is possible to convert by a dark black, that is by means of platinum. Okay, so this is the idea, and by means of by using this galvanic displacement reaction kind of tool or electroless deposition tool, it is possible to fabricate kind of single layers. Okay, why? What is the intention means? It is possible to make a one layer of a platinum or two layer of platinums can be introduced, and thereby it has a very sound applications by means of one atomic layers or two atomic layers. That is the idea. So we just developed, so using a kind of carbon. So we just use a kind of a sheet like a two-dimensional carbon sheets called as a graphene we have used. And graphene material is a kind of just like I hope some of you are familiar with carbon nanotubes or CNT. Okay, so CNT is a kind of a rolled one. Okay, it's a kind of a cylindrical roll. Whereas if you just break the carbon nanotubes, okay, so the roll, if you break it, means it will be a kind of a layer, sheet-like or layer-like, and that is the two-dimensional graphene surfaces, completely carbon surfaces. And we can engineer the graphene surfaces by loading various inorganic matrix like elements or nanoparticles. So ultimately, my aim is here is to introduce platinum on the surface, and thereby, so either say initially I've used the gold surfaces I've introduced over there, and thereby the gold is covered by means of copper, followed by the copper is leached out by means of a platinum. Okay, that is the ultimate aim. So to generate, introduce a gold or copper on the surface of a carbon, and subsequently copper shell formation takes place, followed by copper can be replaced by platinum. Okay, the reason you can ask directly, you can use platinum. Why are you going by means of gold followed by copper and platinum? There is an answer. If you just load directly platinum means there will be a multi-layer platinum may be generated, and it may not have a sufficient activity during the course of methanol oxidations reactions. So gold is one of the very stable one, and when you introduce a gold followed by we know that the affinity of copper towards gold is very higher, so that the copper can be easily introduced on the gold side, and thereby so the copper can be easily replaced by means of platinum because of the better redox energy. That is, as I told you, the energy of platinum is 0.75 and the copper is 0.34. So the energy is higher. So without adding any chemicals or any harsh reagent mechanisms or harsh conditions, the reaction can take place, and thereby so it is possible to make a kind of silver coated platinum or palladium can be introduced. And so this is as I told you, the carbon surface is present, and the carbon surface slowly by means of some of the capping reagents should be introduced, and thereby so when we apply some energy, the carbon can be generated and followed by so with the help of some directing agents, obviously the silver kind of seeds are formed over there, and subsequently the silver seeds, the copper can be generated, and by means of after displacing the copper by means of palladium. Okay, so it leads to create. So it is possible to make this kind of core shell or a kind of a bimetallic kind of materials of our interest. It can be made by means of spherical particles or a kind of rod-like or a wire-like morphology. Whatever of our interest can be generated, and it can be used for any applications. Okay, so likewise. So the same thing is that is when you use the graphene surfaces, the GO is nothing but graphene oxide, and thereby by using the directing agents like tryptophan, you can. So the important role of tryptophan is by using this tryptophan, it is possible to make a kind of a rod-like morphologies. Okay, so it is directing the inorganic elements to make a kind of a rod-like approach instead of a spherical or any other approaches. Okay, that is ultimate aim of this using this tryptophan. So by means of loading the silver, and when we study with silver by means of copper, okay, there is no reactions with respect to the methanol or ethanol reactions. Okay, so the methanol oxidation or ethanol oxidations is not favorable by means of copper surfaces. Whereas if you replace the copper by means of platinum, that is a kind of this is the last step called as a galvanic displacement process, and thereby the oxidation of methanol or ethanol can be easily executed. Okay, as I told you, okay, so it is a kind of a rod-like morphology of silver-coated palladium. Platinum can be generated, okay, by means of it only by means of L-tryptophan. And we just use some of the surface analysis and technique like field emission scanning electron microscope, and followed by EDAX mapping, that is in order to check about what are the elements present over there. So the elements present here is it says that a platinum element is present, the silver element is present. So put together, okay, both the existence of silver and platinum is present over there, and thereby we didn't notice any kind of copper is here. It means that whatever copper is present, it is completely replaced by means of platinum. Okay, so the complete removal of copper to platinum takes place, and thereby, okay, we can. So by some of the other tools like XRD, powder XRD pattern, and okay, not understood about how about the carbon surfaces. The Raman tool is used. Okay, that is the Raman is how about the defects present in the single sheet of graphene oxides or multi-layer of graphene oxide. Okay, it can be understood by means of Raman data. And how about its capacity of the materials towards the hydrogen absorption and desorption? This is a very important tool. So if it doesn't have this hydrogen absorption or desorption tool, then it is not possible to use it, because the presence of platinum is only identified by this process about how it has a very high hydrogen absorption property or kind of desorption activities. Okay. So after that, we just used for in order to study about its current density, about how about undergoing the ethanol or methanol oxidations, and only when the platinum is formed by means of replacing the copper, and it has a very high activities. And we also tried with in the absence of this galvanic displacement reactions, and we just failed that we are unable to give the excellent ethanol or methanol oxidation reactions. And this ethanol or methanol oxidation is very needed in terms of alcohol-based fuel cell reactions. Okay, that is the ultimate aim. So to develop some electrode material to use it for alcohol-based fuel cells. Some of the mechanical engineers, if anybody is there, you can think it of how to you make a kind of fuel cells by means of alcohol. Because in a country like India, we used to have sufficient amount of resources are there for ethanol activities, and thereby, okay, it is possible to create a kind of flex by using this kind of mechanisms. And if we talk about the specific activities, and normally if you compare with the commercial grade of platinum, so the carbon loaded with the platinum are available in the market, and we just compared our data with the platinum with the commercial grade of platinum, and it says that our developed material has a very high kind of efficiency towards a kind of ethanol oxidations, And similarly, the same catalyst is used, and it says that we are compared with platinum, and in the case of methanol also, the comparable activity is present. Okay, so this is the information, the specific activity of the materials we have identified. And in the case of methanol, it is on par with similar kind of platinum resources, whereas in the case of ethanol, it gives very high activities. That is the information we have collected. Just a minute. Okay. So likewise, so here the previous one we have introduced silver coated platinum. So here instead of silver, we have used gold, and we have just studied, is it possible to execute the reactions? So the same surface, the carbon surface is used, and the carbon surface initially loaded with the gold surface introduced, and followed by, okay, the copper is generated by under potential deposition. The copper is generated. The green color morphology is a copper, and by means of the same concept like galvanic displacement, the copper is replaced by means of platinum. And here we just checked by scanning electron microscope about how about the morphology in terms of gold formation or gold coated copper formations or gold coated palladium formations after the galvanic replacement. So in the EDAX mapping analysis strongly says initially, okay, in the first stage, the existence of a gold element is present, and subsequently, okay, when copper is loaded by under potential deposition, it shows the existence of both gold and copper. Whereas after galvanic displacement, okay, the copper is completely removed off, and it says that only the existence of gold and platinum. The green color says the platinum is present. So there is okay, so there is almost a nil amount of copper is present after this displacement reaction. So this is the way that is the copper is completely. So there is no we can completely assume that there is no existence of copper. So it won't interfere in the reactions. The copper won't interfere. So when we checked the size of this material of gold coated platinum by means of high resolution TEM images, and it says that very beautiful spherical particles made of in the morphology of 18 nanometers. It is possible to generate it on the surface of graphene surfaces, I mean carbon surfaces. So when only gold is present, it says that the morphology says that it is almost 18 nanometer is present. Okay, whereas when we introduce gold by the second element like copper, or by replacing the copper by platinum, it says that both silver, I mean gold coated copper or gold coated platinum after galvanic displacement, okay, the sizes remains same. It means that okay, only a single layer of copper or a biatomic layer of copper or platinum is generated. We just checked. We know that about what about the size of the atom, and for 1 nanometers, how many atoms are required, and we just checked it, and it says that okay, the platinum formed on the surface of gold is equivalent to a 2 atomic layer of platinum is generated, and we have just theoretically identified. And our intention is whether a kind of alloy kind of material or a kind of a coercion. Okay, so in the case of nanomaterials, then there is a possibility for forming in a kind of when on the surface, if any formation takes place, it is called as a coercion. Or okay, combiningly both A and B, if A is present and B is formed on the surface, it is called as a coercion. On the other hand, if A and B mixed together, if it forms a kind of a spherical or any morphology, it is a kind of an alloy material. So our intention is to know whether it is a kind of a coercion material or a kind of alloy material. And for those purposes, we used this tool called as a high angle annular diffraction pattern in the STM analysis, and it says that we just taken one particular element of spherical particles, And in the particular spherical particles, we just scanned from left to right. We have scanned, and it says that it is when you scan it is less than 20 nanometers. That is, as I told you, it is 19 nanometers. And if it scans initially, it says that the platinum content is higher, the count is higher. You just see the red line is the platinum, and the black line is a kind of gold surfaces. So when you scan from left to right, the initial count of because what I want to say is here is okay, as I told you, it is an one layer or biatomic layer of a platinum is formed on the surfaces. So it means that okay, at the surfaces from the left, it says that the count of platinum is higher. Okay, so when you just scan from one end to the other end, it says that in between the platinum content is less, and followed by at the end it says that the higher platinum content is present. So it means that it is not present as an Alloy format. If it is in the Alloy format, means the difference should not be present. Okay, the count difference should not be present, and thereby we just identified that a kind of overlaying, that is the gold is present, and a kind of overlaying mechanism of platinum is existed on the surface of gold. So this is the information we have just identified by means of this tool, and we have inferred. And the statistic analysis says that it is okay, so 18 nanometers of only one atoms, only one element of gold, and when a biatomic layer is of copper or platinum is generated, okay, it leads to enhance 1 nanometers. So that is the ultimate result. And by other studies like XRDs and Raman spectra also, we have introduced here to check about how about the activities, and we have checked about the surface area measurements and etc. And it says that it is very feasible in the case of methanol reactions. So when only gold is used, okay, there is no reactions. Whereas when we developed a platinum on the surfaces of a biatomic layer, it gives a very good property in terms of not to undergo the methanol oxidations. Okay, so we just checked about what about its mass activity or specific activity, and also we compared with the commercial catalyst. Okay, so in all these cases, we just evolved about what about its specific activity or mass activity, and it's almost give you a compare results with respect to the commercial materials. Okay, so here the first tool I introduced about the galvanic displacement reactions, and using the galvanic displacement reactions, we just studied by a biatomic layer of platinum on the surface of silver or gold, and we introduced those materials for methanol or ethanol oxidations. Likewise, instead of single elements, right now we want to use a kind of a composites. So when we are planning for a composites, and we thought that the spinel type composites are very better. So what do you mean spinel means? It is a kind of two elements with respect to the oxygen. That is called the spinels. That is normally, if you check in the Google, it will give it like AB2 or 4 or something like that. Okay, so it may be oxygen, or it may be a sulfur or chalcogenides and etc. Okay, so the spinels morphology is very good in terms of energy storages. Okay, so that's why our intention is to fabricate a kind of a spinels. So here, if you check, we just introduce a kind of a nickel tin sulfide as a kind of a material, spinel material, and in the presence of CNTs. So here we didn't use graphene surfaces because in the withstanding capacity for the material is better in the case of CNT compared to the graphene surfaces. We just studied in both the cases, and we found that compared to the graphene surfaces, the multi-walled carbon nanotube, that is MWCNT, is called as multi-walled carbon nanotubes, giving the better properties. So when you make this composite in the presence of CNT, it says that in all these three domains, it is acting as a powerful in terms of acting as a composites. So we can call that it is a kind of a trifunctional material. So it is used, it can be used in the solar cell applications as a, we checked about how about its performance in dye sensitized solar cells, And similarly, we just checked about how about its hydrogen evolution property. And the third property we have just checked is about how about it supercapacitor performance or energy storage properties. The same material, okay, we have just employed for these three different applications. We just checked how about its performance compared to the natural systems or commercial systems. And if you see the morphology of the prepared spinal is just like this dahlia flowers. Okay, so this is the morphology we have just made it over, and it looks like the similar patterns. Okay, it may be a kind of a flower-like morphology. And we just made with a different temperature like 140, 60, and 80, and we identified the particular 160 is a better one. Okay, so here just showing about how about the morphology by means of TEM studies and EDAX. And these are the informations. This information says about how about the crystallinity. Okay, so materials crystallinity is better. Obviously, it can be used for fruitful applications. There is a possibility to make a kind of either amorphous material, that is a powdery material, or a kind of a crystalline materials. And here the crystallinity, okay, so you just see about the rings. So the multiple rings are evolving here, the side pattern, and it says that the generated materials is highly crystalline, and they are used for many kind of whatever applications. So this is the case we just studied about SEM patterns or TEM studies or EDAX mapping analysis carried out in order to check about how about the surface morphology. And subsequently, we just understood about how the spinal is generated, or by means of these are the tool like a powder XRDs and X-ray photoelectron spectroscopy or Raman spectroscopy. And at last, we not to find out the surface area, BET measurements or bed measurements were introduced. Check it out. Okay, so out of all the tool, okay, the XRD pattern says about the crystallinity. And in the case of XPS, it says X-ray photoelectron spectroscopy. It says what about its valency of nickel or tin and sulfur systems. Okay, this is the only tool. It says about how about the oxidation state of every individual element, so that in order to understood about whether a spinal formation is this is the one of the important tool. Okay, what it says that X-ray photoelectron spectroscopy. So predominantly it says that tin 2 plus is higher compared to tin 4 plus due to the Auger electronic effect of SN2S3 and SN4 ions adopting the central positions with octahedral geometry to sulfur and tin 2 plus ions adopting the periphery trigonal biparallel arrangements. And in the case of tin spectra in a NiSN2 S4X shows here blue shift of calculated 0.2 electron volt compared to the pristine element. And in Pauling scale, the electron activity of tin is 1.96, and it is slightly higher than nickel systems. And thereby we have just confirmed that after formation, the electron can be the spinal electron can be transferred from nickel to sulfur or nickel to sulfide to SN2S3. That means that through the in between the two elements like nickel and tin, the sulfur is present, so the electron transfer hopping can take place at the interfaces. So this is the way the reaction takes place, and thereby we have understood. Okay. So here we, as I told you, it has three applications. The first applications we have just studied, like how about to use these materials in dye-sensitized solar cells. So DSSC is called as dye-sensitized solar cells, and using these materials as a counter electrode by using a ruthenium system as a powerful anodic material, and we have developed this material as a cathodic materials. So by various studies like electrochemical studies or impedance studies, we have just studied out, and we just measured the performance. Okay, so this table shows the performance. So we just prepared three different type of this same material. That is, one is the same composites, spinal composites is prepared by hydrothermal methodology, and the second one is B is the same elements after loading with multi-walled carbon nanotubes, And the third one is we just chosen some other methodology like a chemical synthesis in order to cross-check about the performance. So these are the ABC elements, and we normally platinum is a powerful counter electrode in the case of. I think some of you, if you are very familiar in this photovoltaics, maybe you may understood that platinum is a very good electrode. So the platinum efficiency is one of the best efficiency is around approximately 5.23 we are just measured, and when we compare this with our developed system, it says that okay, so when multi-walled carbon nanotube is loaded on the spinels of nickel tin sulfide, it says that the performance is okay. So on nearing this performance, it is possible to develop as a counter electrode in the case of dye-sensitized solar cells. Okay, that is ultimate. Okay, output here. The efficiency is okay better by means of using these materials. And here the important thing is if you just load the CNT only, and thereby okay, so the transfer of electron is very efficient, and thereby the reaction takes place. So in the absence of CNT, if you check, okay, the efficiency is almost 50% less. Okay, it is a 5.23, and in the case of nickel tin sulfide is only 2.38. Okay, so the double the time enhancement is achieved only because of loading with the CNT. Okay, that is multi-walled carbon nanotubes. By loading these multi-walled carbon nanotubes in the spinal systems, and thereby the effective mechanism of electron transfer take place, and thereby okay, so obviously it can be used in the case of dye-sensitized solar cells. Likewise, the second application of these LM systems, we just checked by means of not to check about for hydrogen evolution reactions. So what it says that in terms of hydrogen evolution means here, it is one of the things in order to check about how about the at what potential the hydrogen is evolved. Normally we know that hydrogen should be evolved at 0 volt. Okay, in the previous OER studies I shown you, the whatever thing the oxygen evolution takes place at 1.23, and hydrogen should be around 0 volt. So if you just check in our system at 10 millivolt current appear, if you check it means it says that almost okay, so around less than 0.1 volt the oxygen evolution takes place, and when we compare with the commercial grade of platinum 20%, it gives a similar performance. And we just checked about it in order to study the mechanism. Okay, so how the electron transfer takes place is a one-step reactions or a two-step reactions. If you check it out, and it says that when nickel tin sulfide loaded at CNT, it says that almost its graph is similar to the pink system. So the pink and black is nothing but this is the platinum commercial grade what the normally company has used, and the prepared element is one which gives a similar kind of taper slopes. So the taper slope is less at 43 millivolt per decade, whereas the commercial grade of platinum says that around 54 millivolt per decade. So what I want to say here is since the platinum is very expensive and we can't repeatedly use it, and it is possible to make an alternate material in order to use it for a kind of hydrogen evolutions. And the previous one also we just compared this data with the platinum. Okay, so and it says that similar data is obtained for dye-sensitized solar cells. Likewise, in this case, the same composites when it loaded with a multi-walled carbon nanotube, and it gives a very good taper slopes better than the platinum systems. Okay, that is the thing. And also we just checked about how about the stability of the materials. We checked up to 2000 cycles, and almost okay, if you notice that there is no change between the first cycle and the 2000 cycle for this prepared elements. So that is the ultimate okay, so outcome or benefit of this prepared materials. So in the case of hydrogen evolutions, and we using this double layer capacitance, we measured about how about the surface area, because surface area playing a vital role in terms of activating these materials in order to have a better property. Okay, so after studying the hydrogen evolution and studying about in terms of material as a dye-sensitized solar cell, the third application for the same material is in terms of how to use this material in terms of supercapacitors. So, what do you mean by supercapacitor means? So it says that okay, a normal man can say that what is the difference between the supercapacitors and the batteries? Obviously, you know that the battery is the one we can say that a kind of a marathon race, whereas the supercapacitor is the one it says that it is a kind of a 100-meter race. Okay, we know the difference between the marathon and the 100 meters. The energy for the marathon is different and the energy for the 100-meter race is different. So we can strictly say this is the one thing. So as my friend told that the difference between the supercapacitor and battery. So by means of okay marathon race and a kind of 100 meters. So immediately the energy, very high energy is needed for 100-meter race. Okay, that's why. Okay, so in a short period of time, 9 seconds, people may cross. I mean, okay, the Olympic medalist, gold medalist can cross 100 meters. But the marathon is okay, slowly progressing. Okay, the consistent energy is needed for the battery systems. So in the case of so keeping those things in the mind, we have to develop the material that is for supercapacitors. A very high energy density should be okay, yeah, holded and it should be really released. Okay, that is a thing needed. And for those purposes, we just attempt our material, not how about its energy storing mechanisms. So it says that, okay, so when we checked about its energy storage performance, it says that, okay, when the same composite in the absence of multi-wall carbon nanotube, if you see the galvanic charge discharge, it says that almost 1,000 Faraday. Okay, so whereas if in the presence of multi-walled carbon nanotubes, if you introduce the same elements of nanocomposites, it says that around 1,200 Faraday of energy can be with I mean hold by the material. So that is the ultimate idea or aim of these materials. So we checked about how about the energy density or specific capacitance and okay about the stability. All those data we have just we interfered. I mean we just studied about its performance and obvious ultimately okay our ultimate aim is to make these device fabrications. So the symmetric capacitor should be made up. That is yeah, two layers. That there is a positive layer and the negative layer, and the positive layer and negative layer should be separated by means of a membrane. Okay, so this membrane we just developed. Okay, so normally a Nephrian membrane may be used commercially, but we fabricated this membrane. So here we are just using some protocol that is a polyvinyl alcohol and KOH. Okay, we just make this kind of membrane or okay by a solid electrolytic film so that the anode and cathode can be separated and thereby the device fabrications can be carried out. After preparing the membrane, we check it about how about its conductivity and other things, etc. Okay, so how about the thickness? And the thickness says that it is almost 0.05 centimeters. Okay, thickness is 0.05 centimeters using the profilometer, and then okay, subsequently we measured about this. Okay, I mean electrolytic film about the bulk resistance or conductivity has been measured. So here we just check how about the okay. So the materials are between the anode and cathode. We just make a kind of symmetric capacitors, and the symmetric capacitor says that it is possible to continuously eliminate for more than 100 seconds for this. Okay, using this material loaded over there, and there is a possibility. Okay, so the things that happens. So the construction of energy storage device can be understood by means of continuous elimination. I mean elimination of light emitting diodes. Okay, that is the ultimate. Okay, so idea. So initially we used it for 3 electrode systems, and then we just used for by using the same thing, the 2 electrode systems of both anode and cathode. And the device says that it is possible to make a kind of symmetric capacitors, and the fabrication takes place by means of the homemade membrane. So there is a very important thing. The electrolytic film formation is needed, and it is very economically it is possible to fabricate the system, and thereby it can be used for a kind of symmetric capacitors. And in order to understand that theoretically, okay, how the CNT or multi-walled carbon nanotubes are playing a vital role in the case of using this composite. We just studied some of the theoretical studies by means of total density of states and the partial density of states. How the kind so the thing is how the kind of nickel tin systems and nickel sulfur tin systems are introduced. We just understood the morphology, and here, okay, based on the structural arrangements, we just checked how the things are takes place, and it understood that okay, so the electron mechanism so between the C and D and kind of nickel tin sulfate. Okay, so this kind of front view and side view we have just studied theoretically, and we understood about how the kinds of withholding capacity has been improved in the case of composite by loading with multi-walled nanotubes. Okay, that is the thing. So then, so I think still 10 more minutes is 5 more minutes is there. I will show you some other few slides about how the other elements can be used. Okay, so here we have, instead of the previous one, we have just showed that nickel tin sulfide is used and by loading with the multi-walled carbon nanotubes. So in this case, here we have just used the carbon spheres. And the carbon sphere is generated by means of sugarcane bagasse. So we have just taken the sugarcane bagasse, and by means of that, by using the treating methodology, we made it as a carbon sphere can be generated, and subsequently by loading with the pyrrole element is loaded over there. And very important thing here is here we just develop a kind of different phases of manganese oxide is generated. Like we know that alpha phase, these days alpha, beta, gamma are very familiar, delta and delta because of the COVID. Likewise, okay, we the people always knows that about what in by alpha phase or beta phase or gamma phase. So we just developed 3 different phases of manganese oxide like alpha, beta, gamma in terms of energy, and we just explored how about its energy storage efficiency. And after preparing the 3 different phases of manganese oxide loaded at the carbon sphere, we just checked about how about the surface morphology by both means of SEM and TEM images, and we understood about how about the surface area. So normally you just see in the surface area says that the carbon sphere compared to the normal carbon sphere, when polypyrrole is loaded, the surface area is enhanced from 65 to 98, and when a kind of alpha phase of MnO2 is loaded, the surface area is almost double. Okay, so you just see when the organic matrix is loaded with the inorganic matrix like manganese oxide, and that too alpha phase of a manganese oxide, the surface area is almost double the form of surface area has been improved. When the surface area is enhanced, obviously, okay, so that kind of energy holding capacity may be improved or altered, and thereby, okay, though these systems have been used for better kind of energy storage applications. And it says that the energy storage property is almost 1000 Faraday, more than 1000 Faraday is there in the case of we just studied. Okay, so here we just fabricated a kind of symmetric supercapacitor similarly to the previous systems, and we just checked how about the stability. And here we just checked with the help of normal multimeters. I hope everyone is aware of this multimeters. So here what it says, this means, okay, it says that from 60 to 75 seconds. Okay, in less than 15 seconds, the charging takes place at the maximum. Okay, in 15 seconds, okay, you just see the scale is between 60 and 90. So in 15 seconds, the charging takes place, and thereby slow discharges take place. That is a very important thing is needed in the case of supercapacitors. Charging should be rapidly should taken out, and discharge should be takes place very slowly. So after charging, okay, from 75 seconds, the discharge takes place, almost 50% discharge takes place, okay, from 70 to 240 seconds. So almost in 10 seconds charging, and the discharging takes place almost 15 times higher, 15 times slower. Okay, that is the thing is needed. So slowly discharge takes place up to 240 seconds. So it means that okay, when the discharge rate is higher and when the charging rate is higher and the discharging rate is lower, it can be called as a better material for the energy storage applications. And we just studied this kind of property in these systems by loading the alpha phase of, okay, we have also studied for gamma phase and beta phase. It is not giving a better result only when a carbon sphere loaded with alpha form of manganese oxide. It says that it gives a better data in terms of energy holding capacities for these materials. Okay, so this is the tabular column. We want to say what the thing is, when carbon is loaded with alpha form of MnO2, it says that the capacitance is almost, as I told you, it is 1000 Faraday. Okay, so capacitance is 1000 Faraday per gram. Whereas in the case of gamma form or delta form, it is not giving a progressive results. Okay, so we are just interpreting why only the alpha form is better result. Okay, we are just checking right now. Still, we don't have answer. That is why the particular phase is giving a better property, almost double the property. You just see that it is giving around 500 Faraday, whereas it is giving almost 1000 Faraday. Okay, we want to understand why the things are taking place, but still it is under progress. But right now we can say that when carbon is loaded with particularly one phase of alpha, it giving the better results. Okay, so and it says that when a carbon matrix or organic matrix is loaded with inorganic matrix, alpha phase is better. And the next role we want to understand is when two different inorganic matrices is used, whether alpha is giving better result or gamma is giving better result, and we are just check it out, and that's why, okay, that this one is instead of using a carbon, okay, we have used only the alpha form of MnO2, and cobalt oxide is introduced here. Now to check it out, okay, in 2 minutes I'll just finish it up. That is how the material is used for both the kind of bifunctional properties as well as for that is for energy storage like supercapacitors and oxygen evolution reactions. So we prepared this material of composites loading with the alpha form of MnO2 and the cobalt oxide hydroxides, and thereby we just fabricated this material, and we carried out all the physical characterizations like surface characterization and kind of the elemental characterizations carried out, and this material says that okay, it is also giving an excellent specific capacitance of more than 1500 Faradays. So when we just load the two inorganic matrix, okay, in this case the capacitance rate is enhancing, okay, from 1000 Faraday to 1300 or 400 Faraday, and thereby instead of symmetric capacitors, here we just develop a kind of asymmetric capacitor device is generated, and in the case of the same alpha MnO2 material loaded with a kind of perovskite. So we tried with the spinel structures in the case of nickel tin sulfides, and also we have just the different morphology of perovskite we just generated here, and we just carried out about the asymmetric supercapacitor devices. And here, okay, in terms of eliminating the 1.4 volt LED is glown over there. Okay, and we understood that how the kind of metal oxides is used for discharging and charging purposes. So we just developed some theoretical data, and we identified about the charging and discharging mechanism takes place in the case of during the course of energy storage purposes. And as I told you, it is a bifunctional property. It has both the energy storage property as well as a kind of oxygen evolution property. Okay, so here it says that when we load this alpha form of MnO2 on the cobalt hydroxide, it says that it gives a better result in the case of linear sweep. Okay, so almost okay, giving a better data. So what it says that okay, so when you compare with the tafel plot of commercial plot with iridium oxide and ruthenium oxide, okay, so the data says that it gives almost 240 to 47 millivolt is given, and it is comparable to the commercial grade of iridium and ruthenium oxides. Okay, so with this, I'll just stop it here. And I want to say that one of the summaries we are today, we just made it out is that is okay. So these days the curriculum we need that we have to be very progressive in terms of developing the curriculum. That is in terms of student centric, and whatever material we have just developed here is a kind of a hybrid nanostructured materials. We have just developed with ease, and we use those materials for methanol and ethanol oxidations, and also we just checked for energy storage applications by means of device fabrications, both by means of symmetric and asymmetric supercapacitors. Also, we just touched some of the areas like hydrogen evolutions and oxygen evolution studies, and in terms of dye-sensitized solar cell reactions. Okay, so at the finally, I like to conclude like whatever systems we have developed is a very simple, and it is an economic, and it is very fast throughput, and it has a very stable energy storage devices. Okay, so that is the thing I want to say it here, and thank you for your patience. And I would like to acknowledge some of the funding agencies because without funding agencies, it is not possible to execute any kind of works. So the DST, Delhi or SCRP, and the RUSA under the MHRD, and recently TANSCI has given a sufficient amount from government of Tamil Nadu in this pandemic. Also, we received almost 1 crore rupees from the TANSCI. So we have to financially assistance people. We have to finally acknowledge this. And last but not least, so these are the pillars of my work. Like whoever carried out this kind of work, my students, I should want to really acknowledge all those students. Thank you once again. If there is any doubt or clarifications, I am ready to share. Thank you.
Thank you, sir. Thank you so much for your nice presentation. And this is for questionnaire session.
Yeah.
Participants are kindly requested to ask questions. If there is any disturbance in your audio, kindly post it in the chat box. I'll convey to sir.
So almost 78 members are there, madam? Yeah.
Sir?
Almost 78 members are there, isn't it? It says.
Yes, sir. Actually,
Yes.
participants net availability they are entering into the session, and after listening for half an hour or 40 minutes, they are left out. The first half an hour, we received 99 candidates for the session.
Okay.
So due to the net availability and that fluctuations, we are
Yeah, no problem.
lesser and higher number of participants.
Okay.
Sir, is there any questions? Actually, the Department of Physics madam raised her hand during the session.
Yes, ma'am.
Yes, madam, are you connect with us? There is a question.
Yeah.
Sir, there is a mostly noble metals only preferred. Why?
No, yeah. So I think it is from Dr. Anandan, right? So Anandan has mentioned. Yeah. Thanks for your questions. So it is not noble metals for alcohol kind of oxidations in order to minimize the poisoning effect. We have used platinum kind of material. Whereas in the case of energy storage applications, we didn't use any kind of noble metals. We use normally manganese oxide. I think you have seen the last things, different phase of manganese oxide, and that is very economic one. And also we have used nickel tin systems. The tin is very economic compared to the other elements like gold or platinum. Okay, so it is a nickel tin system we have used, or a cobalt tin hydroxide systems we have used. So in the most of the energy storage applications, we have just used a normal transition and the main group elements. These days we are also using by main group elements also we are introducing. But in order to minimize the carbon poisoning, because you know that in the case of ethanol oxidations and the CO2 or carbon monoxide poisoning playing a very important disturbance. I hope you may agree. So in those activities only, we have used noble metals like gold coated platinum or silver coated platinum or gold coated palladium, etc. So in the case of energy storage purposes, we have used normal transition elements coupled with main group elements as a composites and or as a kind of heterostructures, etc.
Yes, yes. Is there any questions from other participants? So there are no more questions, sir. So
Okay.
actually, we are very, very happy and much fortunate to connect with you for this session, sir. All these works, design and fabrication of higher activity nanostructured electrode materials for the energy storage applications. And next one, the green synthesized procedures you have obtained towards the sustainability of this society make us to work on in this field also, sir. There are many research scholars also in this FGP and UG candidates from agricultural college and all. So hope so this will be the brighter session for them to work in this area. Thank you, sir. Thank you for your wonderful session with us. If
Thank
there
you,
are
ma'am.
any, thank you, sir. Thank you for this
Thank you,
wonderful
thank you,
session.
thank you.
Thank you, sir. Thank you, sir. If there are any queries from the participant side who are left out or who are not getting signal, I'll give the mail ID. You can directly contact
Sure,
us,
sure,
sir.
sure.
Actually, they are having questions, sir. At the session itself, they raised their hand. I don't know
Okay,
why
okay.
they are not coming.
Okay.
So I left this to participants. If you are having any questions, kindly contact us, sir. Directly, I'll give the mail ID. Thank you, sir. Thank you for your presentation.
Thank you, madam. Thank you. Thank you once again, madam. And thanks the participants for the patience. Okay.
Thank you.
Thank you.